Hello students, in this video I am going to discuss a question from the topic definite integration. The question is let I is equal to integral of 0 to 1 minus x raised to 50 whole raised to 99 into x raised to 100 dx and j is equal to 0 to 1 integral 1 minus x raised to 50 whole raised to 100 into x raised to 100 dx. If I by j is equal to m upon n and m and n are co-prime, what we need to find? We need to find the value of m minus n. This is a very tricky problem. Now I'm going to give concepts how to solve these types of problem. It is given that I is equal to 1 minus x raised to 50 whole raised to 99 into x raised to 100 dx. And what about j? 0 to 1 minus x raised to 50 whole raised to 100 into x raised to 100 dx. And I by j is equal to m minus. Now we need to find this m minus n, and m and n are co-prime number. Now what is given? It is given that j is this, that this is our j. Now I'm going to use the concept of integration by part. What we know? We know that integral of u v dx is what? So this is the concept of integration by part. Integral of u v dx is equal to u into integral v dx minus du by dx into integral v dx dx. Now taking this function as u and this function as v. Now using the concept of integration by part here. This is our first function and this is second function. So what we find? We find this j as 1 minus x raised to 50 whole raised to 100. What about integral of x raised to 100 dx? And the limit is from 0 to 1 minus du by dx. This is d by dx of 1 minus x raised to 50 whole raised to 100 into integral of v dx. This is x raised to 100 dx whole dx. And the limit is from 0 to 1. Now simply calculating the values, results, what we find this as 1 minus x whole raised to 50. This I have written here. And what about integral of x raised to 100 dx? So this is x raised to 101 by 101, lower limit 0 and upper limit 1. And what about d by dx of 1 minus x whole raised to 50 whole raised to 100 raised to 50 whole raised to 100 dx. This is by using chain rule. This is 100 1 minus x raised to 50 whole raised to 99 into minus 50 x raised to 49. And what about this? This is x raised to 101 by 101 dx. Now putting the upper limit and lower limit here, what we find, this upper limit, if you put x for our is equal to 1, this is 0, and again this is 0. So j is equal to minus, this minus minus, this is minus and this minus, this minus will become plus, and this whole time is 0. And what about this 100 into 50 is 5000, and this is 101 in denominator, and 1 minus 6 whole raised to 50. And what about x raised to 49 into x raised to 101? So this is x raised to 150. So x raised to 150 can be written as x raised to 50 into x raised to 100. Now we can also write this as this x raised to 50 as 1 minus x whole raised to 50, because this 1 and 1 will get cancelled out and this minus minus will become plus. Now calculating this further, what we find this j as, sorry, it is 101. Now if we calculate this further, what we find this j as 5000 whole divided by 101, integration limit is 0 to 1 minus x raised to 50 whole raised to 99 into x raised to 100 minus 1 minus x raised to 50 whole raised to this and this 100 into x raised to 100 this dx. Now splitting the integral in two parts, what we find this j as, we find this as 1 minus x raised to 50 whole raised to 99 into x raised to 100 dx, 1 minus x raised to 50 whole raised to 100 into x raised to 100 dx. Simply splitting the given in this j in two parts. Now what is this part? Comparing from here, what we find, This is our I and this is our J. 1 minus x is to 50. So what about J? J is 5000 upon 101. Sorry, this is 101. 5000 by 101 I minus 5000 by 101 J. Now taking J left hand side, what we find? We find this as 5101 J upon 101 minus 5000 by 101 I. So this and this will get cancelled. So what about I is to J? This is 5101 whole divided by 5000. So what about m minus n? Simply subtracting 5101 minus 5000. So what about this? This is 101. So hope you understand how to approach this type of problem. So this is very tricky problem which is based on concept of integration by parts here. So thank you and see you in next video.